Hello, everyone. Today we're going to talk about a new vulnerability that was actually issued a security advisory on as the CVE 2025-24813, which is a critical vulnerability in an Apache Tomcat affecting how a partial input put request interact with file-based session storage. Now, Apache Software Foundation issued the advisory on March 10, 2025. Uh, on this video, what we're going to talk about, well, it's going to be a demo, and also we're going to talk about some of the concepts behind what the vulnerabilities, how it could be possible in your environment. We're going to go through it. Now, I just want to state out right off, this is all for educational purposes. We're going to talk about how the exploit is created and all this other information that is required for you to do your test. Obviously, I'm not going to share the entire source code when you're testing using exploits, but I'm going to go through it as for educational purposes, just give you an idea of how, if you would like to create it, how you can create it and all that stuff. So, with that being said, let's go ahead and get started. Now, let's go over the overview of the vulnerability. Then it allows attackers to manipulate how Tomcat handles put requests when using the header called content range header, triggering code that creates temporary files. Now, when it comes to the remote code execution, that is possible. Uh, it's only possible if using session persistence is enabled with Firestore. This could lead to unsafe deserialization from attacker-controlled files. Now, let's go over kind of like why that's the case, right? Why is this the case? First thing, obviously, when we talk about deserialization is session persistences. The session files are saved as serialized objects in a directory. So the the whole premise of the vulnerability is actually if an attacker can control the session files and actually push their session files that has a malicious serialized objects, there is a possibility that the session manager can execute can execute the can carry out remote code execution, allow remote code execution, which is the case, which is what we're gonna be demonstrating on our usual application PinewoodStore, and I have it here. This is actually uh, a Tomcat site. This is just a landing site. So if I were to do this, and as you can see, Apache Tomcat, I just browse to an endpoint that doesn't exist, and obviously, as you know it, Tomcat does provide users information saying it's by Apache Tomcat. Realistically, on production sites, you don't want this information being displayed for the obvious reason, especially if it's vulnerable. No, that's definitely a big no-no. But this is a test environment, so I just left it the way it is. Now let's go back to the vulnerability. Now, what are the prerequisites for the exploitation? To exploit the vulnerability, first thing, you need writable default server. What does that mean? Now, Tomcast has a file called web.xml that's read-only. And there's a parameter, read-only, that is actually part of the web.xml. And by default, that's set up to true. So you need to change that to false if you want to demonstrate this vulnerability. Or if your environment already has it, that might be something you want to test. So the other thing is obviously the partial put support. This is enabled by default, but you just need to know, like I said, how do you trigger partial put support? And you're going to use what's called an HTTP header called content range and also content length. But for the most part, the content range was in combination with content header. If you set them up correctly, it would actually trigger the partial put request. And the third requirement is session persistence. Tomcat has to enable session persistence. It means the session, like when a user tries to access a certain part of the endpoint, uh, the application should be able to create a session and save a file called session file with the extension session on the session directory there's a default directory, and we're going to talk about that as well. I've created the environment, so I'm going to walk you through what it means and all that stuff. So, but basically, to configure this, you need to set it up on you need to set it up like on the configuration file, one of the configuration files. It's called context.xml, and you just need to set it up, and it needs to have the namespace, obviously, Catalina session file store. Basically means the session is going to be stored as a file on that directory where it saves it. Now, the fourth thing that I would say it is a requirement because based on what I've tested so far. Now, full remote code, a lot of the information that I see online is the only thing it was more like a proof of concepts. So they haven't gone through the entire step of testing it. So basically what they did, what they tested for the most part is just to see with the application try to deserialize a Java that is actually being injected using the partial put request. Now, if it tries to do that, like I think it's a proof of concept, so that's basically proves it. Because obviously you're not trying to exploit, especially if you're on the good side, you're not trying to exploit it. But if you want a more realistic approach, and if you want to see how realistic it would be to your environment, you have to actually test it using some kind of proof of concept, and that's what I did. Now, a lot of times, and I noticed actually, there's a tool called YSOSerial. It assists you in creating deserialized Java object that actually executes a command. Maybe opens up a calculator or creates a file on a certain directory or something like that. But now, the reason why I brought that up is, let's say if you create your serialized malicious object, Java object using YSOSerial, what you need to do is actually, for the full exploit to work, YSOSerial depends on the library called Common Collections. It depends on which one version you use. You could use Common Collections 4, 3, 2, 1, whichever one that you use. Now, the Tomcat application needs to be able to access that class, because which I'm going to demonstrate on the live demo as well. When it actually tries to deserialize the object, it tries to access that class. Now, if you don't have the class accessible to Tomcat, the full remote code execution is not going to happen. Basically, from an attacker's perspective, it means there's like extra hurdle. He needs to find a way to actually upload that file so the Tomcat application could be able to find it. And Tomcat application only picks jar files or class files or checks the class files and loads the class file from only specific folders. And we're going to talk about that as well. And with that being said, let's talk about obviously the culprit. In this case is Apache Tomcat Session Manager. What's the Session Manager? It's just a component of Tomcat responsible for managing HTTP sessions, like I mentioned earlier. It handles creation, tracking, timeout, persistence of session data. And every context web application can define its own manager element, and like I said, in context.xml. Now, there's two kinds of manager, the default manager and the persistence manager. Now, the default manager usually relies on storing the session in memory. Optionally, it does write the data to disk during shutdown or failover, but for the most part, it stores it in memory. It's not suitable for large-scale applications due to memory limitations, obviously. So now the vulnerability is actually on the persistent manager. That's why you would have this namespace, and also you would have what's called file store. It's basically saying you're using the file store persistent manager. So the file store supports session persistence to disk. It basically saves the session to a certain directory, and you have an extension called session, and using the store implementation. It can save and reload sessions across several restarts. Now, a store implementation, like I said, it does use file store or JDBC. That's JDBC is for database connection. Now, this vulnerability is entirely going to be on the file store one. And what is the security implications of this? This is obviously what we're discussing about, right? The serialized session objects are stored on a disk, which are session files. If an attacker controlled data is deserialized without validation, RCE mediocre, which is what CVE 2025-24813 is all about. And obviously, on long run, storing sessions as a serialized Java objects, it does open up a lot of doors for deserialization attacks. So that might be something for you to consider as well. Is it worth having this kind of because we might be closing some of the vulnerabilities by setting certain things here if you still need to use it. So now the vulnerable code on Tomcat part that actually allows this is called the execute partial put and the default servlet.java. Where a temporary file is being created with a request path. This is a source code. We're not going to go a whole lot of on that because we're going to focus on the demo. Now, but basically, the attacker can supply a crafted put request. But we're going to talk about the put request and how it's crafted with a malicious serialized session object and place it. Basically, what it does is like just to give you an idea of what was going on is you're going to create what's called an exploit first. And once you create the exploit, it could be you serialize it. Now, serialization is, in Java terms, is when you're trying to save a Java object, first it needs to be converted to what's called byte strings, and because it's easier to save to a file and also transfer. That the process is called serialization, and the reverse is actually converting it back to the Java object. It is called deserialization. That's when the attack happens most of the time. Deserialization attacks. So when it comes to the exploit workflow, it looks like this. First thing, you're going to prepare the malicious serialized session file. You can use YSO serial like we talked about, or you can create your own. Since it's just a proof of concept, it's not going to be complicated. You can have it open up a calculator or maybe create a file in a certain directory. And once you craft that, you can add code into Java code into it where it actually a method that serializes and deserializes. Obviously, when it deserializes, it's going to execute the code that opens up the calculator. In my case, is actually a calculator, and I can kind of give you. I'm not going to be sharing everything, but I can kind of give you an idea of what it looks like. So this is my class. As you can see, just like one class, and it has two methods obviously. And the first method is the one that actually executes a calculator, opens up the calculator. And the second method is actually the one that serializes the object and deserializes it. Obviously, while deserializing it, is just going to trigger the RCE, the remote code execution. And the second class that I created is, since we are actually targeting a service that requires a session file with an extension session, you need to convert the serialized file to a file with an extension session. So that's basically what this class does. It converts it to, I call it malicious, but honestly it's not malicious. It just opens up the calculator. And you can also see it here. And I can also easily convert this to demos this exploit on a Linux machine. All I have to do is just maybe change to genome. I believe genome dash calculator, and it would open up if you're using most of the time when I'm demoing this kind of exploits on Linux, I use Ubuntu. So yeah, genome dash calculator it actually would open up the calculator on assuming that you're using, because if you're using the bare minimum Ubuntu was not going to have that feature where it's not going to have a GUI. So basically, but yeah, you can have it create maybe some kind of file, some directory, because the whole point is just to demonstrate that it can execute um, a code and it can be done remotely. So yeah. And the other thing is obviously the effective versions. This is actually my blog post. It's all gonna be on my blog post, so I'm not gonna go through it. But there's versions that are affected, and these are the fixed versions. Now, the one thing I came across and I want to point out is when after you craft it, obviously when you crafting, this malicious code, I just want to first thing you're going to determine what the file size is based on the workflow. The reason why you need the file size is you're going to use a header called content range, and let's say if it is you determined the in my case malicious session file was 48 bytes, so you're going to put content range and you're going to put 0 to 47. Because you're just showing it's a partial put request. It's gonna be more. So 0 to 47 out of 48. So that's basically what that means. But the content length is 48. What this does is it triggers partial put request. It's basically telling Tomcat, oh, this is actually partial put request. Is actually not the full request. And the vulnerability, as we talked about it earlier on, is on the partial put request. So and that's how you do it. And obviously to trigger the deserialization. In my case, when I actually send a deserialized object to that directory, it actually automatically triggers it because the application would consume the session file and try to deserialize it. And I'm going to demo that. So these are the effective versions and the fixed versions. Obviously, you can get this from my blog. This is my blog, by the way. Now, when it comes to troubleshooting, something I came across is you might get a lot of, when you're using your put request, you might get a lot of photo files. Usually that happens because your request is hitting the JSPs. JSPs by default only permit get, post, or hit requests. So make sure you're not hitting the JSP resource. Instead, you're hitting the default server. Default server then, and it will be successful. And you should be able to actually drop that file, the session file in that directory. Now let's go ahead and start the demo. All right, let's go ahead and take a look at the site or the vulnerable site. So, all right, this is actually in here. Open. All right, so I just gave it kind of like this is a landing page, but this is the Tomcat site, and it is actually running inside an Eclipse environment. And I'm gonna go ahead and demonstrate that as well. And I'm just gonna go ahead and stop it. So it does have those what we talked about. Has nothing to do with that. So yeah, the most important part, obviously. So this is a context.xml. Obviously, it's gonna have this file because we are talking about this session manager with file store. It's gonna be sharing the file. It's gonna be saving the file, session file, for system manager. And the second file we talked about is obviously this needs to be read-only false. This is one of the requirements, and this is just the landing page. I just created it in a way it looks more attractive, but it could be any index.html page. And it runs inside Tomcat 10.0.27. Like we talked about, this is a vulnerable version. If I go back to my blog right now, I believe I have it open. So 10.0.27 means it is actually one of is a, this is actually not the right one. I believe this was updated. Yes. So 10.1.0 to 10.1.34, and I'm using 10.0.27. So it is actually in the range of vulnerable. So now, other than that, yeah, I created it, and obviously in Eclipse, what I did is I went to new and actually created a dynamic web project, and I added this context.xml and web.xml and make sure the configuration, and obviously There are certain configurations that you need to put in when it comes to the servers. You need to download Tomcat, a vulnerable version of Tomcat from a Tomcat website, and download it and then extract it. And after extracting it, what you do is actually you're gonna go ahead and I can actually, well, I don't want to delete mine, but let me see if it lets me add a new server. Yeah, but yeah. So if you don't have this, if I have another application, I would have opened. I don't want to delete it, but what you do is actually you get, okay, it allows me to do another one. I'm not gonna go through everything, but it does allow you to do this. Once you create the application, you're gonna go in Apache, you're gonna select a vulnerable version and click next. And now in my case, I chose that, but just to show you what it looks like when you're adding uh, a new server, let me go demonstrate that on 11. So let's say we're trying to do the 11 one, right? And click next. It's going to ask you for installation directory. And you're going to go back and we take a look at the vulnerabilities page. And when it comes to 11, 11.0.0, maybe you download 11.0.0 or 11.0.1 and extract it to a certain folder in your directory. And after doing that, what you do is actually you're going to click on download and install. And when you do that, it's going to ask you for a directory. First off, obviously, browse to the where you extracted the file that you downloaded for this version. And once you've done that, do download and install. It's going to give you this accept. And it's going to install it. You're going to finish up the setup. Once you're done with that, the server would actually show up here. And you can double click on it and it would come up here. This is my server. I have web.xml. If you want to add, let's say users, you can use tomcat.users.xml. Let's say your demo requires, or you want to make your demo a little bit kind of realistic and you want to add Tomcat users, this is where you want to add it. Just this is a configuration file. I'm not using it, but so after doing that, we're pretty much ready. Let me go ahead and let it stop right now. Now, when it comes to, let's talk about the exploit. So my exploit, you can easily, like I said, you can easily create it this way. Um, YSO serial works best if you're using Java 8. That's why I actually installed Java 8 because I have Java 8. As you can see here, I have multiple versions of Java. And when you have multiple versions of Java and you want to use a specific version, YSO serial is most of the time compatible with version 8, Java version 8. And most machines would have actually either, so by now, this day and age, they're gonna have either 17 or 21 or something. They might not have 8. So you're gonna have to install that. Once you install it, I'm using the what's called WSL. WSL is a, a kind of like a way for you to run some kind of Linux box. In my case, a Ubuntu machine to run on a Windows machine. So this is actually running inside a Windows machine. You can research on that. Usually I find it easier when I'm doing stuff like this, actually kind of do it on a Linux. So instead of even though I do have a full-blown Linux VM in here, sometimes I find it easier to kind of just jump on here. You can also consider this as a full-blown VM as well. But yeah, this is, as you can see, root. This is just running inside Windows. Yeah, point it to the Java version you want to use and -jar, YSO serial. Obviously, you need to download it and save it to this directory that you're running into. And it needs to know which package you're running on. And I did mention it earlier on. This is important because let's say you create a tool. Right now, you're just creating a serialized object that opens up the calculator for Windows. And and kind of like this is what the file name and the extension is going to be. So we can use it. Usually on most other applications, it would have an extension SER. It means serialized. But in this case, since it's actually we were trying to exploit uh, a session manager, it needs to have a session. Because if you put SER, the session manager is not going to try to consume it and is not going to try to deserialize it, even if you actually use a push request. So once you create it, it'll come up here. In my case, because I don't want to deal with a whole part of, like I said, the compatibility thing. Sometimes I run into a lot of issues, and I want to keep it clean. And also, if I need to make any modifications, that's why I created my own separately. But for this test case, you can just use YSO serial and create it, and this way you can run it, and it will save it, as you can see here, in this directory for you, and you can use it. So with that being said, next thing, let's say you're done with creating uh, your serialized object. You saved it as a session file. Obviously now you need to craft the exploit. Or, well, you crafted the exploit, but your put request, because it needs to be specially crafted, partial put request for it to be effective, because that's where the vulnerability relies on. Now, the first thing is obviously you need to find your session file and find the file size of it, because you're gonna trigger what's called a partial put request, and the way you would do it, and I'm gonna demo on mine. So, when it comes to crafting the put request, what you do is actually once you create your session file, serialized session file with the extension session, you're going to go to where it is. Let me go ahead and open up command prompt here. Now, the one that I use in malicious, that session is actually it's giving me the size already. If you notice, it's saying 48 as 48 bytes. Also, if you want to find out, what you can do is bytes or kilobytes. Kilobytes, just dir oh, caps lock. And it's going to give you the exact size here. So 48 bytes. I'm right off, but 48 bytes. Once you find the size, this is actually important when you're crafting the partial put request. So we're going to go back to Postman. Let me pull it up. Now you're going to craft two headers. All right. This is a request, and my root on my application is Tomcat RCE for my application. So you're already on. So the first thing, let's go to the headers. So it's going to have two headers. One is content range, and the other one's content length. Now, my content length, as I've shown you, is actually 48 bytes. So I'm just going to go ahead and put 48. Now, on the content range, you're just going to give it, let's say, if it is 48, you're going to say bytes in 0 to 47 out of 48. It's basically stating that the range of bytes, this kind of triggers a partial put request, because you're basically telling Tomcat when you actually adding this header this is actually a partial put request. And as you can see here, you have put, and you have obviously the URL. In my case, I'm running everything in localhost 8080. The other thing is obviously you're going to go to body, and let me go ahead and just use that, and just click on there, and you're just going to go ahead and select it and open. And after you're done with that, basically just send it to burp. And that's how you craft the request, the put request. I just want to make sure. I give you this information, especially when you see the description on the vulnerability. Sometimes it's vague. It just says specially crafted. The reason why it needs to be specially crafted is because the vulnerability exists when it is actually partial put request. So the way you trigger partial put request is by adding the header this way. What makes it easier? I can actually easily upload files like this. It does give you a lot of options, especially if you're running some kind of a GraphQL testing. It does have its own. I believe Burp has it too, but this does give you a lot of options. I think I like it this way. And basically what I did is I upload my session file here, and I've gone up here and go to the settings. I do have proxy, and I set up my burp proxy is running on localhost 8282. So basically what it does is this request will be forwarded to my burp proxy, which is in here. Let me pull it up for you. So as soon as, let me actually show you that. Right now, this is what we have. If I were to come up here and send it, yeah, it came up. So that's the one. And yeah, we crafted for you this way. That's the reason why I wanted to use it this way. Because if you don't, what needs to happen is you need to change the session file to base64, and you make sure there's not errors and all that stuff. It's not that complicated, but I find it a lot easier, and for me, kind of like, I already use these tools often enough, so yeah, basically you forward it. Once you get it here, you're gonna send it to repeater, and you do have this. And before I do that, let me make sure it started. So my application hasn't been started yet, so let me go ahead and just, I don't know why all of a sudden showing errors, but it's not gonna affect it. This is just an XML, user XML file, and I'm not using any user file, so it's not gonna affect it. Run on server, and you're gonna select yours. Now, before I start this, I want you to pay attention to this. Now, you need to find where your session file is actually going to be saved. But by default, it's going to be inside Catalina. Since my server is running on localhost, that's why you see it here. But I'm going to start dropping the session file here. That's where I would use the vulnerability and the specially crafted put request to push that serialized data in here, so it would actually consume it and deserialize the Java object. So yeah, let me make sure I have only one screen, because the reason why I wanted to do that is sometimes if you have two screens and they exploit my open on another window, it might not prove a whole lot of stuff. So I have to close my second screen. But in any case, before I start this, I've shown you already where the folders are, and I don't have any calculator open right now. Um, so let's go ahead and start the application. All right, they opened up my Tomcat application. And I do have, the good thing is I do have a console log so we can see what's going on right now. And let me go ahead and clear it so I can show you currently. Like I said, this is where the session file is going to be. As you can see here, it dropped the session file because I started the application. I opened up the home page, so it created that session file. All right, now let's go back to my burp where I have this. So this is the bottom that you see on the body. This is going to be the content of the session file. And in here, I'm going to go ahead and give it the session file name. Uh, Hold on, the keyboard. Do apologize. All right, so I'm going to call it malicious calculator mc.session. And let's make sure I can see this only has, it doesn't have that session right now, so I'm going to put everything in this side. All right, so let's go ahead and send it. I got 200, and if I were to open this, you would see it come up in a minute. It actually executed it consumed it already. So I wanted to show you like it, it would show up with the file name. What I'm gonna do is actually I'm gonna try to move my burp to the other screen. That way I would execute it on the other screen, but you'll be able to see there is actually the file appears in this folder. So let me go ahead and you get 200. So let me move this to the side. And I'm going to call it this time around 2. So the session file is going to be called mc2.session. So send it. As you can see here, it came up. Now it's going to be consumed and it's going to be gone in a few seconds. When the application consumes it, it disappears. Yeah, right after it executes it and open up the calculator. That completes the remote code execution. Now, the other point I'm trying to make, I want to emphasize on, I understand some people might be willing to actually test this on their own. One thing I want to, if you create the tool, why so serial, most of the time people use why so serial. If you create the tool, this is one thing you need to pay attention to, which is I run into this problem so much I finally found out what the issue is. And I actually put it here as one of the bullet points when you testing this remote code execution. The last part. Now, full RCE would require the attacker finding ways to upload to the server any Java classes. Let's say if you create yours using YSO serial, you would need to upload the version of common collections that you're using. If we look back on the command, and let me pull it up here. As you can see here, let's say if I create this malicious session file and I use Common Collections 3, version 3. Now, you will need to find a way for your Tomcat application to find access to that file. Tomcat can only, by that what I mean, I believe I have it in here. Let me refresh it. I think I saved it. Yep. Yeah, so Tomcat by default uses what's called web app class loader. This is the one that actually loads the different classes from the jar files. And only knows classes that actually appear in webinf classes and webinf lib inside as a jar file. Now, if any of your dependencies for your RCE tool actually, because these tools that you use to deserialize, they're gonna rely on another class to complete the remote code execution. That's a common thing. if that is not going to work. And I'm gonna demonstrate that in a minute. But yeah, you need to find a way. The attacker needs to find a way to upload that dependency file to this folder. If not, the RCE would not be complete. And let me go ahead and demonstrate that. So in my case, I have this jar file that my executable depends on, or my malicious file depends on. It's because inside a directory that Tomcat application can find, it can actually load up and try to deserialize. And I will also show you the logs from the application. Now I will throw up some exceptions, but it does deserialize it. And as you can see here, I did tell you that I was going to use MC2.session. This is what it is basically doing. And the class that I created is just a malicious calculator. That's what I called it from my showing you my code previously. But basically, that's what it does. This code is deserializing the session file, and doing so would actually execute uh, the code and open up the calculator. Now, this 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 exploit that I create, it does have a dependency on the class malicious calculator, and if I don't have that in a folder that is accessible to the Tomcat application, this exploit is not going to work. That's why I kind of pointed it out as a bullet point. If you're trying to do that, and there might be something, because I was running across a lot of issues here and finally found out what the issue is and resolved it. And I pointed, I put it as one of kind of like bullet points saying, okay, if you need to do this and you create a tool and you have a class, you need to put it in that folder where one of the folders that I shared where the application has access to. And from an attacker's point of view, right, this is going to be an extra hurdle. So that's why, like, even though it would seem on the surface it is easy uh, exploit to carry out or exploitation to carry out. The conditions that need to be fulfilled for this full RC or remote code execution to be possible, multiple conditions, right? So that's one of the reasons why it might not be realistic because for a lot of environments um, to be exploitable. And one of them being obviously this is the case, unless you find a way to exploit the vulnerability using the pre-existing jar files in Tomcat, but those jar files are not known to have any kind of capabilities to kind of execute uh, codes like that that would give you an option to run a command. Uh, yeah, basically that's what it is. Or you would need to find a way to escape the application uh, folder and find another directory where you can download it and actually execute it from there. Even if you do that, the problem with that is uh, the application needs to find it. Let's say you found a vulnerability, but the vulnerability is you can drop this dependency class in one of the folders, but if they're still that folder is still not accessible to the application, then it's just this is not going to be full RCE. Of course, it is vulnerable. The server is vulnerable, obviously. The server is going to try to deserialize it, but they will just throw an exception and it's not going to execute any remote code execution. And let me go ahead and demonstrate that as well. So I have this open. First thing I'm going to do is I'm going to stop the server. And this is the error that we get. And I'm going to go ahead, let me go ahead and clear it out. So let me go to the lib library where I put my jar, and I'm gonna go ahead and just delete it, one of the dependencies. So let's go ahead and go back to the server, and I'm gonna go ahead and start it again. Or I can just do this from the application, run as run on server. All right, my application's up and running. Now, let's go back to my burp. I still have it open. And this time, let me call it uh, MC3. That way we would know, right? So I'm gonna go ahead and send it. I'm still gonna get 209. But if you look in the console, it actually has a different exception now. Class not found. So since it's actually not able to find that class, there's no remote code execution. You don't see the calculator opening right now because you're missing that. So that's one of the requirements if you're creating a real remote code execution where it executes uh, some kind of command that would give an attacker additional control or additional way to kind of take advantage or maybe exploit data or something, depending on what the attacker wants to do. That's the extra hurdle. Like any tool, most tools that actually allows you to execute remote code execution, they're gonna have some kind of class dependency. And if you don't find a way to upload the class to a folder location, those two folders that I was referring to, then it's not going to find the class and the remote code execution is not going to be possible. So finally, what can we do to mitigate against this vulnerability, which is CVE 2025-24813? First thing is patch. Patch has been released. Depending on what version that you're using, you can patch. Anything above 11.0.3 and above, 10.1.35 and above, 9.0.99 above. The reason why I put above is actually most of these is actually that this is the last version, but this is a blog and it can actually be useful for the future, so I don't have to make the change. And the other thing is like security, I'll say security misconfigurations. Set the read only to true and default servlet. That way it's only read only. There is no write. Actually, by default, read only is set to true. To do this, to demonstrate this remote code execution, we have to set it to false. And the other thing is, this is very common in a lot of applications, and that's why a lot of applications sometimes get exploited. If you don't use a feature, just disable it. Don't leave it in a default state. Like for instance, most applications don't even use partial put requests, so you can disable it. Apache Tomcat has a way where you'll be able to disable partial put request. And the other thing is avoid using persistent manager like file store, like sharing, saving this to some directory, the session file to the directory plus this file is actually a serialized Java object, which introduces another set of vulnerabilities, which is actually very common when it comes to Java, which is the deserialization attack. So the other thing I can say is always validating strict deserialization sources. So final thought. So CVE 2025-24813 is just a reminder. The dangers posed by deserialization and misconfigured server components. And while not exploitable by default, a handful of changes can actually convert a banking setup into a critical vulnerability. We've seen it because most of the time, sometimes you might think it's not vulnerable. For instance, when we talked about the remote code execution, one of the reasons, one of the required points is if you're using a tool like YSO Serial or any other tool where it actually executes a code when it gets deserialized, is it relies on another class, and Tomcat has to be able to have access to that class so it can actually successfully deserialize it. By doing so, executing the code and allowing the attacker ground. You might think that, oh, okay, that's like a say, kind of like it would be hard for an attacker to do, but what attackers do sometimes is they combine multiple vulnerabilities, and he might find another vulnerability. What he'll be that would allow him to upload that specific class to one of the directories where the application can access it, and by doing so would make it your system fully compromisable or exploitable. So that's why I kind of like leaving things, assuming that the best will happen and there's no way for an attacker to do this, is not a good practice because uh, an attacker, most attackers, most of the time, they combine multiple vulnerabilities. Sometimes even a vulnerability that is actually considered a medium severity was in the past has been used by attackers to compromise the system. So that's all I have for today, and thank you for listening and watching.